In the previous video, we have seen the code writing for the 8 for an adder of 8 inputs, which is of 8 bit. Now in this video, let's look how to write a test bench for it, and how to compile using model sim, and how to simulate using model sim. Okay, I'm just showing the code for it. Um, these are the codes for the this is the code for the off adder, and this is the code for the uh, whole module of the uh, 8 input adder. Now we are now in this video, along with test bench, let us conclude the compilation and simulation. Let us look what is the test bench. The test bench is nothing but the testing of the DUT, which means design under test. At present, we have the design an adder under 8 input, so we have to design. Uh, so you have to test it. How can we test this? Uh, by giving some inputs of known inputs and observing the output. Let us suppose if you consider an adder, simple adder, which is a 2-bit adder. It consists of 2 inputs and 1 output. So we fed inputs at ports, 2 input ports, and observe the outputs. If we give a known inputs to the known 2 inputs, we know that the output is known. So whether the required output is obtained or not. So is what in the test bench. So let me draw the figure of it. Let us suppose this is an uh, let us suppose this is an adder. These are the inputs and this is the output. So we have now in addition to this module, let us suppose this is the module which we have written, not the 8 input adder. Let us suppose a 2 input adder. We additionally connect a test bench. This is the test bench in which testings, some inputs are fed and outputs are observed. The main purpose of this test bench is to fed inputs, inputs and observe outputs. Just feeding the inputs. So this test bench module has no inputs and no outputs. It just fed the inputs and observe the outputs. There are basically 2 types of testing, namely randomization and corner cases. The name itself indicates randomization, that we select a random numbers of our own choice which we don't know, and these are to be fed to the test module. Generally we here this is the test module. Okay, this is the test module. So this can be written this can be called as DUT, design under test. DUT module. So from the test bench, the inputs are fed to the DUT and the output from the DUT is observed in the test bench. The main purpose of the test bench is to give inputs and observe the outputs and has to wait for some time for the next inputs to process. Okay. So drive inputs, observe outputs and wait for some time, and all these put together we can call it as some set 0. Similarly, another set 1, so on, like this up to n number of sets which you have to be tested. That means you have to given in inputs and observe some outputs, and like these cases we can do n number of times. An interesting thing here is stimulus, which means wanted inputs. Okay, in randomization we drive inputs randomly and observe the outputs which are correct or not in the randomization process, and in the next case, that is randomization violation, and secondly corner cases. In the randomization we pick up random numbers and fed as inputs. In corner cases we look at the corner cases. Let us suppose take a 3 input adder in which the input is 3 A B C. So let us consider each input is 1 byte. So each inputs must be either zeros. So there may be a possible of 8 cases: 0 0 0 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. In these cases we consider we consider only corner cases, that is either ABC or 0 or 1 1 are fed in the test bench for feeding the inputs to the DUT. And this is basically what is called a test bench, and we have to write a code for it, test bench code. uh, Generally uh, when we done a project we consider mainly the three folders, namely RTL, SIM and TB. The RTL, in the RTL folder we do the code for the design modules and instantiation, like this, so on. In the RTL module, RTL is only for the design, and TB is the test bench which is used for testing, and you have to write the test bench code in the TB. And the and SAM means simulation, and while compiling and simulation we go use sim. um, One thing, in the test bench we have to initialize a block. So what is initial block? Let's look at it. Initial block. This block is only for testing and simulation only. So basically it's only for testing and simulation, and the code in this block is executed one after the sorry other, and it execute only once. Only once. So basically we consider stimulus as the inputs fed to the fed in the test bench, and you have to declare all the stimulus inside one initial block. So put all your stimulus inside, let me correct, inside one initial block. There may be case of multiple initial blocks. So you may use only one initial block, or you may initial n number of multiple initial blocks. Suppose in this case we have used the DUT as adder only. If your module consists of adder along with a subtractor module, then we have to uh, initial a block separately for adder and separately for subtractor if our inputs are differ based upon our convenience. So if you have n multiple initial blocks, these different initial blocks executes parallelly. Is it clear? Parallel means if it consists suppose if it consists of two blocks, okay, let's apply the subtractor. So we have initialized two different what we say initial blocks, and these two one initial block adder module and one initial block for the subtractor module, and these two blocks executes parallelly. That means these two can be fed inputs parallelly. It will be more clear when we go to the code for it. Let's see the syntax for the initial blocks. Syntax for the initial block. The syntax for the initial block is you have to initial. It's very simple. Initial keyword begin and some lines which we will discuss in the code part. Some set of lines, some set of code, and end. There is no opening braces, not like this. Just initial begin and end. Simply the syntax for the initial block for in which we have to write the fading inputs here. So this is basically how the syntax of the initial block looks like this. Now let's move forward to the syntax of the test bench. Test bench. This the initial block is a part of the test bench. Okay. So the syntax for the test bench is module space tb. open braces, close braces, semicolon. Note that this is the module and the module name is we have written as TB, so that we must save the file TB. Okay, and the next set we can declare. I'm just typing see and observe. It will be easy for it. So I have to declare the inputs, so I have to declare the outputs. Initial block for simulation. So you have to declare the initial block. The syntax of it is look like this: Control C, Control V. Initial begin somewhat. Then so uh, now our final module is along with the test bench, and the DUT is our now final module. This whole slide is the final module. This slide is whole slide is our final modules. So we have to instantaneous these modules in it. So we have to, the next is instantiation of the, let me correct, instantiation of the DUT, design under test. That means you have to connect some heading lines, and you have to declare it, and finally end module. This is how the syntax of it will look like. So it is a case sensitive, so all are small. Let me say this M is small and E is small. Okay, this is the syntax of the test bench. Okay, let me give a brief glance about what we have discussed now. So we started our discussion with the test bench. A test bench is nothing but use it for testing and use it for testing. The test bench consists of one, just it has no inputs and no outputs, as we given no inputs to it and no outputs to it, but it just fed the inputs to the DUT and observe the outputs and wait for some time, and these three process we can call it as stimulus. Stimulus is nothing but wanted inputs. Okay, there are mainly two types of testing: randomization and corner cases. As the names indicates, it is easy, and the stimulus is nothing but wanted inputs. Like this, we have n number of sets, just inputs, outputs, and waiting for some time. Nextly, we have discussed about the initial block, which is a part of the test bench. This initial block is only used for testing and simulation. The code in this block is executed only for once, and I am just saying what you are seeing in this slide. Okay. And it executes only once. Put all your stimulus inside one initial block. That means what you have to given as inputs to your DUT, you have to initialize in the initial block only. There may be case of multiple initial blocks, and these multiple initial blocks executes parallelly, and the most important thing is uh, the code in the block executes one after the other, but when you compile it, it seems to be that there is no they all the code is executed at the 0th time. That means it appears to be that all is executed once, not by step, as The processor speed is very fast. It seems to be like that the code is all executed at the 0th time. This is what we have discussed in the initial block. Later we have discussed about the syntax of the initial block. It's simple: initial begin and some of the initial statements and followed by end. Finally, we have discussed about the syntax of the test bench, which is the main part of it. And the initial block syntax is a part of the test bench syntax. And it is very clear as I shown here. Okay, let's move to the syntax code for the test bench for an adder of 8 inputs.